Let's find the solution to the given linear inequality. We'll begin by transposing 2 from the right hand side to the left hand side. This will give us x plus 3 divided by x minus 2 less than or equals to 0. We'll combine the two terms. So we'll have x minus 2 in the denominator. In the numerator, we have x plus 3 minus, we'll multiply 2 with x minus 2. So that will be 2x plus 4. So this is less than or equals to 0. We have negative x plus 7 divided by x minus 2 less than or equals to 0. We want to make the coefficient of x positive in order to solve the linear inequality. Since it's negative, all we have to do is multiply both sides with -1. But before doing that, we'll have to use the fact that if we have two numbers a and b, and let's say a is less than or equals to b, and we have another number c which is negative, then if we take the multiplication of a and c and b and c, then the sign of the inequality changes. Then a times c will become greater than or equals to b times c. That's exactly what we're going to do. We're going to take a value of c which is -1 and multiply to both sides. So we'll have x minus 7 divided by x minus 2, but the sign will change to greater than or equals to 0 times -1 will be 0. So this is the linear inequality that we need to find the solution. So to solve this new linear inequality, what we will do, we'll consider a number line. On this number line, we are going to find some critical values. Now, how do we find out the critical values? To find out the critical values, all we have to do is consider the numerator, x minus 7, and equate it to 0. Then we'll also consider the denominator and equate it to 0. Solving for x gives us x equals to 7 and x equals to 2. So these are the two values that we'll plot on the real number line. So we have 2 followed by 7. Now, we will have three regions here. So this is region number 1 for values of x between -∞ and 2. We have another region for values of x lying between 2 and 7, and the third region where x value is greater than 7. So we'll consider some number in region 1. So here in region 1, let's consider x equals to 0. And we'll substitute this value into a rational expression, x minus 7 divided by x minus 2. So that means we have -7 divided by -2, or simply 7 over 2, which is a positive value. So that means our region 1 has become positive. And it's true for any values of x. Any values of x, as long as it's less than 2, we are going to get a positive value. You can check out for other values of x as well. Next, we will consider region number 2. Here we'll take a value lying between 2 and 7. So let's take 5. So if we take 5, so we're 5 minus 7 divided by 5 minus 2. So 5 minus 7 is -2, and 5 minus 2 is positive 3. So that means we are getting a negative number in region number 2. Fine. So we'll take this region 2 as negative. And for the final third region, we are going to consider another value of x. So let's say x equals to 10 and substitute into a rational expression. So we have 10 minus 7 divided by 10 minus 2. So that's 3 over 8, which is a positive value. So any number of x which is greater than 7 is going to give us a positive value. Now coming back to our linear inequality, we have to find a solution. We have to find the region along this real number line where x minus 7 over x minus 2 is positive. So clearly it's region number 1 and region number 3 where we have positive values. So this is the solution. Now how do we find out the solution? We'll write it in the interval form. So that means we have our solution running from -∞ to 2. We'll come back to the intervals in a moment. Union 7 to positive infinity. So we know that -∞ is unbounded. So that's why we're using an open interval. What about 2? Is x equals to 2 included in the solution? That's not true, because if we look at this linear inequality, if we put x equals to 2, then it's a division by 0, which is not allowed. So that means we have to exclude the value of x equals to 2. Now, coming to 7 to infinity, of course, it's always unbounded. So we'll have an open interval. What about the value x equals to 7? Is it included? Let's see. So if we substitute 7 into our expression, so we will have 7 minus 7 divided by 7 minus 2. So that means we have 0 in the numerator, which gives us 0, and obviously 0 is greater than or equals to 0. There's an equality sign. So that means we have to include x equals to 7. So this is the solution set to a given linear inequality. Now, in graphical form, we can also represent it as, so we have all the values going from negative infinity to 2. Here 2 is not included, so we'll put a bubble here. And all the values greater than 7, so here 7 is included. So we have from values going from 7 to positive infinity. Right. So this is the graphical way, this is the interval way, and if we want to write in terms of x, then we have all values of x less than 2 and all values of x greater than 7. So this is another way of representing a solution. So these are the 3 different ways.